Hey guys, here are the notes for Unit 3 on congruent triangles and proving triangles are congruent. This is actually about 3 sections, so it might be just a touch longer. I don't think so. You can see up here there's only 7 slides, so it's not super long, but there are some things that I really need you to go over. So these are on congruent triangles. These two triangles are congruent. Congruent meaning that one triangle would land right on top of another triangle and you would not see the bottom one because they would be perfectly the same size. This triangle right here, if I flipped it around, this A would land on this D, this B would land on this E, this C would land on this F, and the triangles would be perfectly congruent. You could see that all this side is one tick mark, this side has one tick mark, this side has two, this side has two, so those two are going to be congruent. The ones with 3 tick marks are congruent to the 3 tick marks, and it's the same in the arcs. One arc would be congruent to one arc, and so on. So in this triangle, I could say, or in these two triangles, I could say that triangle ABC is congruent to triangle DEF. And the order of the letters is important. If I label this as ABC, that's one arc to 3 arcs to one, or 2 arcs to 3 arcs to 1 arc. I have to do the exact same order over here. 2 arcs to 3 arcs to 1 arc, so DEF. The order matters because in this little problem right here, A matches up with D. And you have to have A matching up with D in the order because A and D are the congruent angles. Letter B matches up with E. So if this triangle was flipped over, it would land on top of E right here. So the order matters. C matches up with F. So it shows which sides and which angles match up. I could also do side AB, the first 2 letters, and that matches up with side DF, or DE, the first 2 letters. So AB has 1 tick mark, DE has 1 tick mark. Those are my 2 first letters right there. So the order does matter. Now, when 2 triangles are congruent like this, all of these pieces are congruent. And what we call that is corresponding parts of congruent triangles are congruent to each other. And the letters that come out of that are C, P, C, T, C. And I kind of listed it down here. Corresponding is the C. P is for parts of, congruent. T is the triangles are congruent. So if you read it like this, corresponding parts of congruent triangles are congruent, which just tells you that if you know that 2 triangles are congruent, now you know that all of the pieces of the triangles are congruent. Every piece of this triangle is the same as every piece of this triangle, and you could list them all. Now here's a conditional statement for the CPCTC, for those letters I was just showing you. If, there's your conditional because it's got an if 2 triangles are congruent, if they're congruent, then all the corresponding parts are congruent. So if you can prove that 2 triangles are congruent, now you know that all the sides are congruent and all the angles are congruent. So let's look at these 2 triangles, and let's see if we can list all of the corresponding parts of these triangles. We know that B is going to match up with E because those have an arc and an arc. We know that AC is going to match up with DF because those have 1 tick mark each. So in this case, for the sides, AB would be congruent to DF. That's got 1 tick mark to 1 tick mark. AC and DF, yeah, we already did that one. AB on the top, AB would match up with DE. That's the first one here, AB and DE. And then BC down here on the right side would match up with EF. Remember, order is important. So if you list B and then C, you've got to list E because E matches up with B. You got to list E and then F. So the order does matter in the way you put these things. If I was to put the C in front of the B, then I would have to put the F in front of the E. So order definitely makes a big difference. As far as the angles are concerned, angle A matches up with angle D. Angle B matches with E. Angle C matches with F. We can see those there. So basically, I could take this triangle like this and line it right up underneath this one and you'll see what lines up on each other, and those are your congruent sides. So A lined up on D right there, you can see B landed on E, and C landed on F, and then the sides landed on each other as well. So that's when you know they're congruent, when one lands right on top of another. Since you've got all this stuff that's congruent, now you can say that triangle ABC, A to B to C, has to be congruent to D to E to F. E had to be in the middle because B was in the middle. E and B are matching up, A and D are going to match up, C and F are going to match up. C is third and F is third. They're going to match up. And if you notice the sides even, if I was to put a line right here, AB, that's going to match up with DE right here. And you can see that right here, AB and DE matched up. Same thing with BC, the last two, and DF, the last two. So there it is right there. All right, now we want to be able to prove that two triangles are congruent. So there's 5 ways to do that. There are 5 ways to prove that triangles are congruent. Let me go over these 5 ways here. First one is called the SSS postulate. This one is a postulate. So let me write that down. I don't know if you remember what a postulate is, but a postulate is a statement we can accept without proof. We don't have to prove it, it's just true. If you have 3 sides of one triangle congruent to 3 sides of another triangle, the 2 triangles are congruent. It's not something you have to prove. If you look at these 2 triangles, this is like the opening for a tent. You got the zipper down the middle here. You've got this triangle right here. You've got this triangle right here. So they got a 5 in common, another 5. So those 2 are the same sizes. 3 matches with 3, so those 2 are the same. And AB matches up with AB in both triangles. AB is congruent to itself. That's called our reflexive property. If I was to put AB as congruent to AB, that's a reflexive. So it shows the opening for a tent. Can you prove, with capital letters there, that the triangles are congruent? We can look at them and say, yeah, they look congruent. This triangle right here looks exactly the same as this one, but if we want to actually prove it, that's why I put this in capital letters right here. Capital letters to prove. Can we prove that these triangles are congruent? Well, yes, we can, because AB is congruent to itself. That's our reflexive property. And I probably should put a little line on top of AB here. Segment AB is congruent to itself, so AB is congruent to AB. Plus I could put 1 tick mark there to show that those 2 are congruent to each other. And the other 2 sides are also congruent to each other, so I could put 2 tick marks here. That would be congruent to 2 tick marks over here. And then I could put like 3 tick marks down here. And that would be congruent to 3 tick marks down here. So it shows that side, side, side is congruent to side, side, side. And a lot of times on these triangles, we actually write the letters like S, S, S is congruent to S, S, S. That way you see the 3 letters, you see the postulate right there. So the answer is yes, that FAB has to be congruent to CAB. F matches up with C, and A matches with A, so you can see both A's are in the middle. And then B matches up with B. Both B's are in the middle. So that was yes. That's the SSS postulate. We could definitely prove those. The second way is the SAS postulate. It's another postulate. It's another thing that we don't have to actually prove. It's just a given statement that we know is true. And the postulate basically says, if 2 sides and an included angle of one triangle are congruent to the same in another triangle, then the triangles are congruent. So in other words, if this side is congruent to this side, and this angle is congruent to this angle, and I know that both of these have this side in common right here. AB is in both triangles. So that's another side congruent to another side. What that's showing me is that you have the SAS postulate, is that side angle side. If this stuff is congruent in a triangle, if this part is congruent to this part in the triangle, I don't need to measure the other pieces. I can say by this postulate right here that if you've got a side, an angle, and a side congruent to another side, angle, side, now in this case the angle has to be between the two sides. It's got to be SAS, S-A-S. The angle's got to be in between. The two sides of the angle have to be your two S's. Then you don't have to measure this stuff anymore. You know you've got congruent parts. You know you've got congruent triangles. So can you prove that these two are congruent? Yes, because BC is congruent to BD. AB is congruent to AB. That's, again, our reflexive property. Angle 1 is congruent to angle 2. So therefore, you can say that CAB is congruent to DAB by the SSS postulate. Those are congruent because of the SSS postulate. So that means this triangle is definitely congruent to this triangle. The third way is the ASA postulate. If you've got two angles and the included side of a triangle are congruent to the same in another triangle, then the triangles are congruent. So remember, this time the side's got to be in between the two angles. So here I've got a picture of two triangles. I've got an angle here that's congruent to this angle down here. I've got this angle over here congruent to this angle. Now notice they all have one tick mark. That means this angle is congruent to the angle. This is actually an isosceles triangle because this side has to be congruent to this side if the two angles are equal. All of these angles have one tick mark, so they're all for the same angle. And in the middle, you have a side congruent to a side. You could just basically see the postulate sitting right there, ASA. It's right in front of our face there. It's got an ASA postulate. So can you prove that these two triangles are congruent? And the answer is a resounding yes. Yes, you got these angles are congruent to each other, and UW is congruent to XZ. So the two triangles are congruent by the ASA postulate. ASA. Remember, pause it anytime so you can get them copied. The fourth way is called the AAS postulate. Angle, angle, side. And you might have noticed that there's one set of letters that does not work, and that is the bad word letters. If you have an angle with two sides, that does not prove that triangles are congruent. You cannot use the bad word, which is angle, side, side, and have it prove that triangles are congruent. It just doesn't work. So the only ones that work are the ones I've given you so far, which was SSS, SAS, ASA, and an AAS. So if two angles and a non-included side of a triangle are congruent to the same in another, then the triangles are congruent. So you might see on this one, I've got an angle here next to an angle up here, and my side is not between the two angles. It's outside of the two angles. I've got the same thing over here, angle, another angle, and then a side that's outside of them. And you might notice that if I flip this triangle, it'll land exactly on this triangle. So these angles match up, the outside angles match up, A matches with L, C and N match up, they're both the obtuse angles. So this is an example of the AAS theorem. Angle, angle, side is congruent to angle, angle, side. And you can prove it with this theorem. This postulate actually works. So this actually works. You can prove it. Angle A and L are congruent, angle M and B are congruent, and BC is congruent to MN, therefore the triangles are congruent by the AAS postulate. So they are congruent. You can prove it because you have enough information. You're just hoping to have enough information. If they give you an angle side side, that's not enough information because that's a bad word and that does not prove. You could actually make two different triangles with an angle side side. So, but if you've got an angle, angle, and a side congruent to another angle, angle, side, you're not going to be able to make two different triangles. It has to be congruent triangles there. And the last slide, of course, there is one more to come in the next section. There's one more because I said there was 5 ways to prove it. So far I've only given you 4. And here's your challenge. Today's challenge is a puzzle. You need to tell me what the answer to this puzzle is on your mark, set, and go. So there it is. Pause it if you need it. Bring me the answer. First one that can bring me the answer wins. And we'll see you guys later.